Hello, everyone. So we are going to explore another question using the sum to product formulas of the trig identities, and also we will try using a bit different way as well using the angle sum identities. Okay, so let's go ahead and start with like we have cosine squared x and minus sine squared x, right? So if you recognize those, which is one of the identities that we have, which is the like double angle identities. So just a reminder, so like cosine squared theta minus sine squared theta was equal to cosine of 2 theta. So if you are not sure why this is the case, then you can just use the angle sum for cosine and use both angles are equal to each other. So, and then simplify, you get this one, which is easier to deal with that. And the same idea with this sine. So if you use the like the sine of the 2 theta, this was equal to 2 times sine theta times cosine theta, right? So now the problem telling us these like together, like it just cosine squared x and minus sine squared x. This is equal to cosine squared of 2x. So I'm gonna go ahead and write that. Okay, and then the middle term is just the double angle of first sine, which is basically the sine 2x, and this is equal to 0. So at this point, then you have two different ways, at least, that we can try. The first thing I like to see, we have like a cosine of some angle and then sine of some angle. So like we don't have any um, identities other than using sum to product, because the like you can try making the like this equal to 0, like I'm making a tangent as well. What I mean by that, you can subtract 2x from both sides or cosine, I mean, sine 2x from both sides or cosine 2x from both sides. If I subtract like cosine 2x from both sides, or without really doing that, maybe we can just divide both sides by cosine 2x. If I divide by cosine 2x, that will be just 1. And then that will be sine 2x over cosine 2x, which is just the tangent of 2x, and this is equal to 0. So now we have tangent 2x is equal to -1. So you can try like solving this equation from here. So I'm going to leave this part for you to see if you can finish that problem. But I will use the sum to product because I do have a cosine and then there is a sum of sine, but we don't have anything in between cosine to sine, like when you add them to get a like product relation. So if you have like cosine, cosine, or sine, sine, we could have something like that. So for that reason, I'm gonna make this guy same as this one. But how do I do that? So I'm gonna replace sine 2x as cosine of pi over 2 minus 2x. Okay, so that is equal to 0. So this guy is the same as this one, so we've seen this a lot. And now we have cosine of 2x and cosine of pi over 2 minus 2x, right? So now we have the sum of the two cosines, which can be written as product of the cosines, if you remember. So let me remind that. So if I have cosine alpha plus cosine, like let's say beta, this is equal to 2 times cosine of the sum of these are the angles and take the average basically times cosine of the difference between those angles and take the half. Okay, so this is the sum to product for cosine. Okay, so when this in between is the positive, okay, which is what we have. So then if I apply this, right, then I should be getting 2 times cosine of this sum of the angles, like 2x and this guy. So if you add those, the 2x will cancel. You get just pi over 2, but there's like half as well. So that will make pi over 4 times cosine of the difference of those two angles, like 2x minus this guy. So 2x minus pi over 2 minus of -2x. So that will give us 4x minus pi over 2. But there is a 2 as a denominator. So if you divide 4x by 2, which is 2x, and then pi over 2 divided by 2 is going to be pi over 4. So we will get minus pi over 4. So that is equal to 0. So now we have a product is equal to 0. So cosine of pi over 4 is not 0. So only way that will be equal to 0 if this is the 0. And cosine of something is going to be 0 if this is like pi over 2 radian or 90 degrees or 270 degrees, which is 3 over 2 pi. And the question was asking us to find a solution in between 0 to 2 pi radian. So let's get the solution in that interval. So if that's the case, this angle, which is 2x minus pi over 4, is equal to either pi over 2 or 2x minus pi over 4 is equal to 3 pi over 2. But if I just leave it this way, there's something missing, and then I do miss some of the solution if I'm not really completing my solution. What I mean by that, I need to add any multiple of the period of the function. Since this is a cosine, which is any like multiple of 2 pi's, could be added to this number to get the same result, which is 2k pi. Why do we need? Because if this part is negative, so I need to add like at least 2 pi to that number to get a positive in my interval. So that's why I need to add this guy. And this is also added right here. So now I'd like to get x itself. So let's add pi over 4 to both sides. So that should give us 2x equals, if we add pi over 4 to this guy, this is 2 pi over 4. If you add another pi, so you will get 3 pi over 4 plus 2k pi. And divide by 2. So the x would be 3 pi over 8 plus k pi. Okay, so that is something. But now, since we are looking for the solution in the 0 to 2 pi, so this is for sure one of them. I'm going to call this is x1 as the first solution. So 3 pi over 8. But if I add like pi to these numbers, I'm going to still get something smaller than 2 pi, which is also another solution. So my second solution would be 3 pi over 8 plus 1 pi if I choose k to be 1. So that will be 11 pi over 8. And I cannot add anything more. Otherwise, it will be bigger than 2 pi, which we don't want. So we have two solutions from this part. And for this one, like, let's add the same thing. So that will give us 2x. If you add, like, this is 6 over 4 pi. If you add one more, so that will be 7 pi over 4 plus 2k pi, right? And divide by 2. And x is going to be 7 pi over 8 plus k times pi. So another solution now we got from the second equation, which is I'm going to call x3, is 7 pi over 8. But also, I could have, like if I choose like k is 1, that will be added like pi to this number. So that is going to be 15 pi over 8. So we have 4 solutions to this equation in between 0 to 2 pi radian by using the sum to product properties. Okay, this is something we could do, but I do have something slightly better than this, especially if you don't really remember the like sum to product like identities for cosine. So I'm gonna stop having this part, so which is still we can, but I'm gonna see if we can do something else. So I'm gonna clean the whole thing. So the next approach like is by basically using the angle sum for like sine or cosine, which you can just use either way. So like, you know, I like angle sum for sine. Maybe I should, the reason I'm saying this because I do have like a couple ways to prove it, which was my first identity that actually we try using some geometric figure. So which is why I'm gonna try writing this equation a different way to get angle sum for sine. So like, for us to do so, I just need to remember sine of, let's say, a plus b, right? And this was equal to sine a cosine b plus like cosine a sine b. So this is what we see, but we do need like two more things that will be product, which we don't have it. So maybe we can think about when this is the case, sine and cosine are equal to each other. Why do I care about when they are equal? Because if I multiply this equation by a number that is equal for their sine and cosine, maybe that will make angle sum identity for sine, all right? So, which is like 45 degrees or pi over 4. So like if I multiply this equation by square root of 2 over 2, why this is the number I choose? Because this is the number that is equal to sine 45 or cosine 45, okay? And if I multiply this by both sides, this 0 doesn't change. But I'm going to rewrite this a bit differently. So if I multiply these, so let's see how this is going to look like. I'm going to write this first. Like I'm going to say sine 2x times this number. So the root 2 over 2 plus and cosine 2x times root 2 over 2 is equal to 0. So now I'm going to replace this number with the like cosine 45, which will be sine 2x times cosine of pi over 4, because this is the same as this number, and the cosine 2x times sine pi over 4. So I hope you see what's going on now. Because we have sine of 2x times cosine of pi over 4, cosine of 2x, and sine of pi over 4, which is exactly angle sum for sine, which we can just write as sine of 2x plus pi over 4 equals 0. And the sine value of something is equal to 0. So that will happen if the inside of the sine function is 0 or 180 degrees, or just like pi and 0. And you can just go from here. So I will say 2x plus pi over 4 could be 0 or pi, right? And now we have the similar reasoning as the first approach, and then the rest you can handle easily. I just want to kind of show this approach as well, because this is kind of a bit smart way to look at that problem, and instead of using the sum to product identities, okay? So I hope that was clear. I'll see you in the next video.